Hello everyone. So in this lecture we're going to look at this web applet which is available for you for free of charge. This is at MathOpen reference. So you can use this site, but I don't suggest you to do that because at this stage of your life, your imagination is very important. You have to use your imagination to visualize these things first. So for the sake of this lesson, I'm gonna use this applet, so I don't suggest you to do so. uh, okay, so in this lessons we are going to look at quadratic functions in this form ax squared plus bx plus c. You are familiar with this form from ordinary level lessons, so I can skip forward on that part. Okay, so in previous lessons, last time actually we were looking at linear form of these types, which means a equals 0. Here in the linear form the x squared term does not exist, which means the a equals 0, a part, but bx plus c exists. So this is the general form of a linear function. Here this is quite similar to y equals mx plus c, which is you are familiar with. So those are not that different. These are just their coefficients. Naming of the coefficients has changed, that's it. So let's see how this works. I'm gonna make a equals 0 here. Now you can see that all the coefficients of these terms are 0, which means y equals 0. So last time, you can see here the y equals 0 lines is the x-axis. The red line represents the plot. So what happens if I change the intercept? Intercept means c, which means now a and b are both 0, but I'm going to change c. That gives you y equals c. So what happens if I increase it? You can see here this plot goes up, goes vertically, it shifts vertically, and when I decrease c, it shifts down vertically. So this is what the intercept does. It does not change the shape or the orientation. Now you can see that y is parallel to x-axis. It doesn't change, it only shifts the function up and down. Now let's make it 0 again. Okay, now let's see what happens when you change b. So when you change b, means a equals 0 and c equals 0, but b can change. So that means y equals bx4. So what happens? So when you increase b, you know that slope increases, so the straight line rotates. About what? About the origin. So when you decrease b, it rotates clockwise. And finally, when you get to negative sides, you can see here you have the negative gradient of the line, but still it is rotating about the origin. That's all this b does. So let's make b a value. Let's give b a value. Let's say b equals 1. Now let's change c. Let's see what happens. You can see here that the line will be again shifted vertically, up or down. So this is what c does. You can see here that c, when c equals 20, it cuts at 20, y equals 20. So this is what b and c does, right? B rotates, as you can remember, b rotates about the intercept. That's what b does. C moves the straight line vertically up and down. Okay, now let's make all of this 0 again. Now look at the quadratic form. So we'll first look at the simplest form of the quadratic functions, where only a is not 0, b and c are zeros. So this is the form of y equals ax squared. So let's see what happens when you change a. Now a equals 0 at the moment. If I increase, now a equals 1, you can see the general shape of the quadratic functions. So what happens when you keep on increasing a? Okay, so you can see here that the quadratic functions becomes more curvy when you increase a. This is what the coefficient of x squared does to the parabola. It changes the shape. So what happens when a equals negative, right? So this again, it curves the functions, but now you can see here that the function has been uh, flipped along the x-axis. Okay, so when a is negative, you get a maxima, and when a equals a is positive, you get minimum values for y-axis. This is how you uh, characterize the quadratic functions, whether it is a minima or maxima, based on the sign of a, based on the sign of the coefficient of x square. When it is negative, it gives you a maximum value for y, that's why you call it a maxima. When a is positive, you get a minimum value for y, that's why you call it a minima. So let's keep this function at a particular value. Let's say a equals 2 here, which is a positive one, so you get a minima. Let's see what happens with the function when you change c. Now b is 0, let's change c and see what happens. So when you increase c, you can see here that the function shifts upward. So when you decrease c, the function shifts downwards. You can see here when c equals 0, what happens? C equals 0, the function, this form, the minimum value will be 0, right? So this function touches the x-axis at the origin. That's all what it does. So when c becomes negative, you can see here what happens. When c becomes negative, this function cuts the x-axis at 2 points. When c equals 0, it only touches the x-axis. When c becomes negative, only in this form, when c becomes negative, you can see here that it cuts the x-axis at 2 points. What do you call these 2 points? These 2 points are called the roots of the quadratic equation. So when this term becomes 0, the 2x value that this function is c equal to 0 is called root of this function. So what happens when you change c, keep on increasing, and c becomes positive? The function goes up. The c does not change the shape of the function, but you can see here now the function does not cut the x-axis at any point. So which means the function at this specific locations, the function do not have any roots. So as you can remember from your earlier lessons, you know that for a quadratic equations, you can either have two real solutions, or one solution which is called the coincident root, or the third option is that it does not have any solutions. No real solutions uh, occurs in a case like this. You can see no real solutions means it does not cut the x-axis. So you can see here in this form, it does not cut the x-axis because it is much above the x-axis. So when c becomes negative, you can see here that suddenly it starts cutting the x-axis. So now you can visualize in this form how the function looks like, where the location of the function is, and whether it has roots. How many roots? If it has roots, how many roots it has? If it doesn't have roots, you know. Okay, so let's make them all 0 again. Let's change a to 1. And let's see what happens when you change b instead of c. Let's keep c at 0. Let's see what happens when you change b. Now what happens? Right, so it goes in a circular path, I believe. But you can see here when you keep on changing the b as well in this form, the number of roots will change. But this is quite complex for b here. So it is actually when b equals 0, when a and c are not equal to 0, you can actually visualize the function. But when b comes into play, it's quite difficult to visualize this function. So this is what's wrong with this form of this quadratic function. So we're going to look at a new form of this quadratic function, which is obtained by using the completing square method. So in that form, you can actually visualize the graph directly, but in this case, in the general form, you can see here that b is quite complex. it's quite difficult to get into any conclusions uh, based on the b value, that means the coefficient of x. Okay, so we'll stop this video here. If you have any questions, you can ask me during the discussion. Okay, thank you.